I'm going to draw a diagram here, and you're going to learn to love this diagram. We're going to send, I'm going to have to keep this. I'm going to have a switch number 1. I got switch 1 over here. This has some ports on it. It has let's see if I can draw this really nice. It's not going to show up on your TV screen. How many ports is that? 1, 2, 3, 4, 5, 6, 7. So there's 7 ports on switch number 1. I have a PC down here, and it is connected to port number 2. All right, we are all okay with this, right? There's an RJ45, unshielded twisted pair comes out of here into my switch, okay? Either way, there's going to be a cable running into there, so that's in port 2. This has a MAC address, and I'm just going to abbreviate it. This is A1 44, and then there's the rest of the MAC address. All right? All right, this one connects to switch 2, and I'm going to draw switch 2 up here. So switch 2 is like my core switch, right? I'm going to draw in my little squares on here. Look how good I am at this. Okay, so switch 2. I connect switch 1 to switch 2 from port 5, 1, 2, 3, 4, 5. And it needs to go to port 3 on switch 2. Then I'm going to have a switch 3. Luckily that's the end because I just need to show a nice simple hierarchy here. I'll draw my squares here. Okay. Switch 2 connects to switch 3 from port 7 to port 4. It shows up. It's nice that they switched to high-def video here. Oh, there's my head. Look at that bald spot. Oh, this is the front of my head. Oh well. Alright. I'm getting old. You guys know it.
Coming up in 5 minutes.
Yeah, I gotcha. We'll be done in 5 minutes. We're fine. 1, 2, 3, 4, 5, 6. Let's get Nancy in there.
Ooh, my bad. Actually, we are almost out of time here.
Well, your clock's off.
We got a 3:40.
All right. Oh, we're supposed to just stop at 3:40? Okay. All right. Well, this one is plugged into port 7, and it's E5. And it's got a, so that's its MAC address. So I'm going to have to save my little diagram, save yours too, for next week. I'm going to go back now, which is actually, we had started this last class. I was making this diagram. And we're going to talk again about how easy Ethernet is. So here I drew this diagram, and I've got, 2 workgroup switches and a core switch. Let me get to where I was. And we're going to draw some more workstations here. I'm going to draw one over here that is connected on port 7. I'm going to go to 7. 1, 2, 3, 4, 5, 6, 7. So on port 7, I have another computer. This computer's MAC address is B2, and then it has a bunch of other stuff. There's another computer up here on port 1, 2, 3, 4, 5. This one is, should I make that be a server? I should change that to a server. That is my core after all. So this is a server, and its address is C3, and then it has a bunch of other bits to it. Can you read that? Are you guys okay reading this? I don't know how I would do any better, sorry. E5. And then I have one more over here. This one is connected into port 2. I have one more computer, and that one is D4. Okay? So where did these MAC addresses come from? So this one's A144. In case you're interested, it goes D5, 1F, AA, 4C. So it goes all the way out, 48 bits worth. 6 octets. Where did this come from? This number, MAC address? You remember that?
Was it from the manufacturer?
Comes from the manufacturer, right? So when I turn my computer on, it has the network card connected to it, and it's already been addressed. So that's the number there. All right, what we like to have is the switch needs to have a table. So I'm going to put a switching table up here. So this would be the switching table for switch number 1. This will be number 1. This one is number 2. Oh, and that's number, oh, I already have it. 1, 2, 3. Okay, I don't need to do that. So switch number 1 has a switching table in it. In the switching table, it has a port. So there's a column for the port. And then there is the MAC address. Okay, oops, MAC. Okay, so I have a column for a port and a column for a MAC address. Now let's think about this for a minute. I'm going to use green since green is the only one that seems to work. Let's just say in our imaginary world here, this computer A1 is about to send, or it's going to send a frame that's to E5. So we're trying to get over here on our network. All right? So in the frame, you all remember this, right? We had our frame, we had the preamble, started frame delimiter, you all remember that stuff? First thing that comes up is the destination. And the destination is E5, blah, blah, blah. And we remember this, even though I wrote E5, I'm a person. In the computer, it's just a binary, bunch of binary stuff, bits. We're good with that, right? 48 bits. So it's got a destination on it. So this is the frame. The destination is E5. The source is A1. All right, so this is our green frame coming off of here. And there's a lot more to the frame. There's a little bit that came before here. But this is what the frame looks like. It comes out this port, okay? And it goes into there on the switch. Okay? In an ideal world, the switch is going to look here. This switch number 1 will get that frame. It's going to look up in this table and see where it goes. And it's going to say, oh, that goes out this line, right? We talked about this last time, right? The frame should come in one port and only go out one other port, right? You remember that. So I'd like it to go out here. Then it's going to come in here. And then I'd like it to go out here. And then it's going to come in there. And then it's going to come out here. We like that, right? That's the whole idea of switching. It only goes out the port that's on the data link to where it's going, right? Now, look at this switch number 1. This switching table is empty. Number 2 also has a switching table. That one is also empty. Switch 3 has one too. And why is this empty right now? Like, why would a switch have an empty switching table? You guys ever used a switch before? Like, you plugged in your router at home. You guys remember that? And you plugged in your computer into it, and you plugged in your Cox connection to it. Did you all write any MAC addresses and port numbers in there? No. Ethernet is plug and play completely. Like, it'll work with these being empty. When you first buy them, they are empty. Are we cool with that? The other thing about a switch is I can go in and I could actually unplug this one and unplug this one and plug them in different places, and it would still work. Ethernet, 100% plug and play, dead easy. Okay? Now, here's my question. So let's assume right now, okay, we're blank here. This switch number 1 just got plugged in. It's brand new. We just plugged everything in and we flipped it on. Now I have this client that's sending out this frame. What is this switch going to do that it doesn't know what's going on the network, where anything is? What is it going to do that's going to make sure this frame gets to its destination? Like, what would you do if you were switch number 1? you weren't sure where this frame goes, but you need to make sure it gets where it's going.
Would it do a check, does this exist kind of thing? Does.
That would be a big hassle. There's a lot easier way to do it.
If it's on its switch,
No, E5 is all the way over here.
yeah.
You would do a what? I do a broadcast. So all I have to do, since I don't know anything, is I send it out every port. I'm not sure, by the way, it might go out here, but I don't remember. But I send it out every port on the switch, a broadcast. Now, what is B2 going to do when it gets this frame that's addressed to E5? It's going to what? Just ignore it, right? We talked about that last time, right? It just ignores it. This is the same kind of Ethernet as when they're all connected to the same wire, all right? But it'll still go up here. So the frame comes up here just like we wanted it. When it gets to this switch, this one's empty also. So it does the broadcast too. And here, this server is just going to ignore it. It still comes in here just where we wanted it. But it's going to broadcast again. This D4 is going to ignore it, and E5 will get it. Okay? Now, we can't have these broadcasting, otherwise, why did we buy switches in the first place? We want them to make these tables, right? How can we, let's just think about A1 as the source, sending to E5. How can these switches populate their switching tables? So when this A1 sends that frame, does switch 1 learn anything about what's connected to it? Yes. What does it learn?
What it is, what its address is,
What is?
what A1 is.
It learns what A1 is. Y'all seen that? As A1 just sent the message, so it just came out here, and it went into port 2. You see that, right? So what do we know as a switch about port number 2?
It's back.
What MAC address? Do I put, which one of these do I know? The source. Why don't I know the destination? Because I haven't gotten anything from them yet. If I'm a switch, I can only learn from the source address. Are we good at that? That's awesome. Come on. There's no way to know. I mean, we don't know the destination. That's why we broadcast it in the first place. But if you hear something with the source address of whatever MAC address, then we can populate our switching table. All right, so the frame, that same frame again, is broadcast out here, and it comes out all ports. What does switch 2 now know?
The MAC address.
Port 3 is offline.
Port 3 is for, what does it know about port 3?
That it can communicate with one, but I don't.
It only goes to A1, okay? All it knows is it just got a frame addressed from A1 on port 3. That's all it knows, and that's all it can put in there, okay? That's all you know. Ethernet's real simple, but it does work.
Switch to switch information.
It doesn't know this is a switch. It doesn't know anything. It just knows A1 is this way. If I want to get to A1, it's this way. All right, what does switch 3 learn? What are we on here? 1, 2, 3, 4. This is port 4. And we now know what's out port. What is out port 4 for switch 3? A1. You guys remember this is A1. Let me get all the things in. A1, 44, D5, blah, blah, blah. Okay, it's 48 bits long of something. Okay, this is a huge number. I keep putting A1 because I'm lazy. And you guys did it too, but remember it's 48 bits. All right, so now we've populated our switching table a bit. And now E5 is going to send the response. Okay, that looks a little orange. What does the response from E5 to A1 look like if I'm drawing it as a frame? Like this. The destination is A1. The source is E5, okay? This is a new frame coming out, destination A1, source of E5. Are we cool with this? So this is its response. So A1 sent something, hi, how's it going? It's going great, okay? That comes marching back, all right? Now, when this frame, destination A1, source E5, gets to switch 3, what does switch 3 do? It's going to do two things. It learns the MAC address, and then where does it send that frame? Is it going to broadcast it? Right, now it knows destination A1, it looks up in its MAC address table, now there's something here. A1 is in port 4. So this frame is only going to come out port 4. He's not going to send it over here. Are we good with that? So now the switch is acting like our normal switch. So that goes out port 4, and we also said we learn what? What's going to be added to our switching table? E5 is 1, 2, 3, 4, 5, 6, port 6. Okay? Now you guys can fill in. What is number 2 and number 1 going to be? Go ahead and fill in what happens here, draw your frame wherever it goes out here and where it goes out here, and fill in these. This will be like your Jeopardy quiz. And I'll sit here and hum the Jeopardy theme while you guys fill that out. And relax a little bit. I gotta lean back once in a while. So I totally messed up my back. What was it, the week we had when we got out at 3? That was 3 weeks ago. And I'm finally like, it doesn't hurt anymore. I'm old. All right, you guys are going fast or something. Oh, there's my nose. It's a nice little camera there, huh? See, that's what I was doing last time, was I was trying to, part of me is that. Oh, that's my hand. I was trying to stay out of the way of the camera, so I was tilting over. Oh, now you're going to show me, okay. Well, hi. All right, are we ready? There's a couple people here writing still, but they'll be all right. All right, so we learn here E5 for switch number 2 is connected on 1, 2, 3, 4, 5, 6, 7. And then over here, I'm going to have E5 is on 1, 2, 3, 4, 5. Right? Now, this is getting a little messy. So I'm just going to scoot this away. And I'm going to look at the back of this one. And I'm going to finish the 2 or all 3 switching tables. Since you guys don't have big old fat, since you guys don't have big old fat pens like I do, you can do this a little better on your notes, hopefully. Okay, we'll just ignore that part. So here's number 1. There's my port, and there's my MAC. And I'm just going to fill in the whole switching table for switch 1, switch 2. I don't know why I'm doing it over here. Let's do it right there. And then I'll put number 3 up here just because I like it. All right, so I've got, on switch number 1, I already have a port 2 is A1. On port 5 is E5. On port 1, 2, 3, 4, 5, 6, 7 is B2. Okay? All right? So this is after a while when these switches have been running. There's still more to come. So I've got C3, that was that server. That's coming out of on switch number 1. To get there, I need to go to 1, 2, 3, 4. Port 5 is how I get to C3. And then in order to get to D4, that's also out port E5. Right? If I look at switch number 2, I already had port 3 was A1. I have port 7 is E5. I then need to add D4, which on switch 2 is going to also be out port 7. I need to add B2, which is going to be on switch 2 out port 3. And then I need my C3, which is actually on switch 2, that's in port 5. Okay, so let's just go through this again. So there's my original diagram, and here's switch 2, right? So port 3 here, that's how I get to A1 and B2. Port 5 is where C3 is connected. And then port 7, which is out here, that's where E5 and D4 are. Right? So let's finish off switch number 3. I have port, where am I at? Switch 3 is port 4, goes for A1. Port 6 is for E5. Port 2 is for D4. C3 is going to be out port 1, 2, 3, 4. And then, what was it? B2 is out port 4 as well. All right, so here are a couple of lessons we can learn just by looking at this. Number 1 is I can have the same port number appear several times. Why does this port 4 appear a lot of times on switch number 3? Because I'm connecting up here to another switch, right? Okay. So these are different MAC addresses. Oops, there they are. A1, C3, and B2 are on port 4. Okay. That tells me as a human looking at it, we're connected to a switch. The switch does not know that. Okay. It has no concept that this is a switch. It just knows that's where these are. If I get a frame to C3, it needs to go out port 4. Are we good with this? Switches are not smart. Remember that. 3 here. Not smart. Smart. They are not smart, so remember that, all right? So if we look at 2, so here's 2 again. I can see that out port 3, I've got A1 and B2. There's another switch coming out here. Port 5 is C3, and port 7 is E5 to D4. And just to note, even here, sure, I've got port 5 as C3. This could even be, there could be a switch here between me and C3. Are we cool with this kind of stuff? That's no problem. The switch doesn't care what this port is connected to. All it cares about is whether the MAC address goes out there. Okay? So 1 is the same way. If I look at 1, I've got 2 as A1. E5 goes out this port 5, which is that switch. Oops. Port 7 is this B2. That's not written very well, sorry. 5 goes to C3, and 5 goes to D4. Okay? So look at these. If I'm going to have 85 PCs connected just here, 210 connected in here, and another 80 over here, how big is the switching table going to be in this one? It's going to be pretty big, right? We're cool with that, right? It's going to have 85 plus 210 plus 80 plus whatever is connected to it. So that's going to be, 400 or so entries. All right, so this one's going to have 400 entries. What's one of these out here in the workgroup area going to have? How many entries? How many entries are on each of these switching tables? There's 1, 2, 3, 4, 5 workstations on this network. How many entries on these MAC address tables? 5. There's 5 on this one, even though it's a workgroup switch. There's 5 on this one, even though it's a workgroup switch. 5 on this one, that's the core switch. So how many table entries are going to be on just one of these workgroup switches? 400 here. No, it's 5. No, is it 4? 3, 4. Yeah, 400. There's going to be about 400 on this switch. How many is going to be out here?
400.
400. You know, 400 all over the place. Okay? This is one thing you need to also to remember is your switching table depends on the size of your network. If I go out and buy a little tiny switch that you would get at Best Buy and connect it into this huge network, the switching table on that little baby switch isn't going to hold probably 400 entries. It'll hold a lot because a little Best Buy switch, you know, it might have 4 ports on it. You know, it doesn't think it's going to connect to more than, let's say, 10, but memory's pretty cheap. So it'll probably hold 20 or 30, maybe even 100, but it's not going to hold 400. And if it doesn't find something in its MAC address table, so if this, you know, if this only holds 5 and it, you know, a couple more come on, if it doesn't find the entry for it, then it just broadcasts it. So we kind of lose out on it being a real switch if we buy underpowered switches for our network. You guys see that? It still works. Mention that again. Even if you connect these together wrong, as long as they're connected together, it will still work. It just doesn't work as well as it could. Okay? And it works well enough, by the way, like I said here, if we connected it wrong, if we put in one of these switches and uplinked it, everything is still going to work. And our boss will be happy because it'll work. You might have a consultant come in and they'll be like, look, you need to rearrange your server, you know, some senior guy. But the senior person only makes, you know, maybe 6-figure-ish. And if he comes in and says, or she comes in and says, look, you connected your network wrong, they're not going to say you need to fire whoever connected them in this funny way. So my point here is don't be afraid of this. Just connect your stuff together and it'll work. And somebody might come in later and say, yeah, here's a better way, but it's not going to get you fired. So don't be scared. All right, so there's my switching tables.
The first time you set it up, it'll set up all the Macs.
It'll just learn them, just even in this configuration where I did all these huge things.
So if it was theoretically completely messed up, could you just like reset it and then it'll set all the Mac address stuff?
Yes. So if this was set up wrong and I had these like this, I could just go in and put this stuff in later and just fix it and unplug what I needed to and plug it back in, and it all fixes itself.
Yeah, what I'm saying is like, instead of actually unplugging it all, couldn't you just like reset the switches themselves? So
There's a
that they'll set
reset
up the Mac
button.
addresses?
Oh, yeah, we'll just talk about that in just a second. They actually don't. Well, just a note here. So I've got this switching table. Interestingly enough, every once in a while, it just empties the whole thing out. Just to say like, okay, some of these entries might be old now, I'm just going to dump everything. It just dumps it every once in a while. It's just, because it's going to learn them really fast anyway.
So then you move port, when you're in port 2 and you move to port 3, it reminds that, and then try
Mhm.
to send something to port 2 and it's not there anymore, is it going to broadcast?
It doesn't happen like that. What happens, this is fun. So if let's say, so we're looking at number 1, so we're on number 1 here, and I unplug A1, I take this wire out of port 2 and I plug it into port 3. Oh, we haven't seen any of that stuff in here, sorry. There's actually a voltage that goes down the wire all the time when it's plugged in. Have you ever seen that on your network when it says like network unplugged? Y'all seen that? A little thing comes on, it says network unplugged. Well, the switch detects that. When you unplug it, it detects that there's no longer a circuit completed there. So when you unplug port 2, the switch is just going to erase that entry, right? And now I've plugged it into port 3, so the next time it gets something for destination A1 that comes in, it doesn't know where A1 is anymore because it deleted this entry, right? So what is it going to do that it doesn't know where A1 is?
Broadcast.
It just broadcasts it, right? And then when A1 replies, it's going to learn that A1 is now on port 3 in just a second. And so this is totally, they're pretty robust in terms of like, you can unplug stuff. I can unplug out here and plug stuff back in. The same thing here, if I unplug port 5, I just unplug that and then plug it into port 4, The switch detects the circuit's lost, and it just deletes all these entries.
So it always broadcasts initially.
Yeah, it'll always broadcast. And once you unplug it, now it's forgotten everything that was on that port. It'll just automatically forget it.
So,
And then it'll learn it back again. Yeah.
with all these broadcasts, what's the point in even memorizing all the MAC addresses to begin with?
Well, every time yes, why did you memorize them to begin with? It does make a big difference. There's a lot of chatter on these networks. I mean, you'd be surprised at how much traffic, even on this network that had 5. These clients are always, anytime you web browse, there's, 8 or 10 different frames going out. And if I send them out, I'm going to get replies back. And really quickly, it learns where I am. And so that makes it so, multiple people can talk at once, is basically the bottom line.
Is it the same like when you have your computer home, you have your USB, and like, oh, I stuck my camera in here, and then I stick it over there, and wherever you,
Yeah,
it's
more or
just
less like
gonna-
that.
It's just gonna learn that.
Mm-hmm. Yeah, this is actually a little more elegant because it doesn't really learn. This hasn't learned a lot about you. All it knows is what your MAC address is.
Okay.
And so it doesn't know, like we said, even though it says, yeah, it doesn't know that this is a switch. It just knows there's a MAC address. And so it's even faster in terms of being able to respond. Okay? So here's our big lessons. Even though it sees multiple ports here, it doesn't think there's a switch. It has no concept of switch. It only knows MAC address. And we also learned, that was very useful, that if we unplug one of these, it just forgets what was on that port. And just to extend it a little bit. So let's say I unplug this. S2 is also going to forget everything that was connected to port 3. So boom and boom goes out of S2. Okay? But notice switch 3, if I can get switch, oops, I don't know. So these get forgotten, boom and boom. But switch 3, nothing was unplugged out of switch 3, so it still knows or remembers, for example, that B2, C3, and A1 are all out port 4. And it doesn't forget those, but they're still in theory there. Just when these frames get to switch 2, now it doesn't know this link is here, and so now it goes back to broadcasting. Remember, switch 2 lost those 2 entries?
So it'll broadcast to find out where they need.
Yeah, so it'll broadcast because it doesn't know.
And then next time it won't broadcast.
Yeah, well, because, when the reply comes back, it'll know where everything came from. So everything's sort of, it really, these stay pretty well. We're acting like these broadcasts, there's a lot more broadcasting that happens than this stuff. And that's more of a problem, because there's a way to just say, broadcast this. We'll talk about that as we go on. Okay, let me make sure where we are. So that was switch learning. All right, so one other thing. There is a single possible path. And I think I talked about this when we talked about an extended star. Let's put it up here. A single possible path. You guys need to add this below your notes. We'll put an exclamation mark there. Anytime you want to go between any 2 stations, there's only one path between them. So B2 to D4, there's only one way to go. B2 to E5, one way to go. A1 to E5, there's only one possible path. The way that is enforced is there is one entry per MAC address. Okay, in a table. Okay, this is a primary key. You guys know a primary key, right? It's unique. These MAC addresses are unique. Okay, A1 will only appear once in this list. That's because there's only one way to get to A1. This is why switch networks are set up in these extended stars. Okay? One possible path between any 2 stations. MAC address only appears once. MAC address only appears once. Okay? There's no choice here. So we'll put here one path. Since there's no choice, one path equals you get faster response. There is only lookup response. we only have to program a lookup, we don't have to respond a choice. So there's no if-then statements in a switch. It just looks up where it needs to go. Okay? Single possible path. So between any two stations, there's only one path. Even on our big old complicated network here, there's only one possible path. So if I'm coming in here, I'm going to go down here, and I might go to that server. Anyway, there's only one set. There's only one path between any of these stations out here and any other station. We're good with this, right? One. So the MAC address is unique.